All right, guys, things about to get ugly. Ugly, okay? So our most inside function is going to be this guy, and that's what I'm going to make u equals. So I'm going to say u equals 1 plus x squared. When I do my derivative, I get du dx equals 2x. And then I move the dx to the other side. And I look up here, I don't see a 2x dx. And so I need to do a little bit of manipulation. I'm going to put a 1/2 on the other side. So I'm multiplying both sides by 1/2, and I have an x dx. Now, I can make this have an x dx, which is what I'm going to do. I'm going to rewrite this really quick and then start subbing stuff in. Okay, so let's say this is the antiderivative of 1 plus x squared. And then I'm going to say x to the fourth times x to the fourth times x dx. Okay, so now I have the things I can easily take out. Like this guy's going to be a u, and this guy right here is going to be the du. But then we also have to have the 1/2 with that. Okay, so now if I rewrite it, it looks like this. I have a 1/2 out in front. Okay, you should always try to take the scalars out. It makes the anti-deriving more simple. I have a square root of u, and then I have a x to the fourth, and now I have a du. Now, do you see the problem? We still have an x. That's a problem. Okay, so now what you have to do is a little extra. All right? Now there's different ways to do this. You don't have to do it exactly my way, but there's different ways to do this. I'm actually going to, I'm looking over here at how u is related to x. And what I'm going to do is I'm going to get the x squared alone. So if I get the x squared alone, it's going to be u minus 1, and that's going to be the x squared. Why did I do that? Well, I can split this guy up into two x squareds. Okay, he can be two x squareds, an x squared times x squared, right? So now I'm going to sub out the two x squareds for the u's, the u terms, the u minus 1. Wow, more subbing? Yeah, we're trying to do some gnarly manipulation so we can get all the variables to be the same. So we have u raised to the 1/2. I got rid of the square root, made it into 1/2 power. And then we have a u minus 1 and then a u minus 1 du. Okay, now before I do any anti-deriving, I still want to simplify our integrand. We can simplify our integrand more. So if I multiply this out, I would get u times u, which is u squared. And then I would get u times -1, which is -1u. But then I have a -1 times u again. So technically it's a -2u. And then I have a -1 times -1, which is a +1. There's my du. And that's multiplying to u to the 1/2 power. Times 1/2. Okay. Almost done manipulating, and then I can finally do some calculus, do my anti-derivative. Okay, so what do I get? I'm going to go u times u squared. Don't forget, what do we do with our exponents when the bases are the same? So what do you do with the exponents? You add them. Okay, now I have to have common denominators, and so I'm going to cross out this 1/2, and I'm going to make it into a 4/2, so I get u to the 5/2. Whew. Now we go minus. Now this u has a 2/2, right, a 1, and so I go 2/2 plus 1/2. That would be -2 u to the 3/2, and then I have a u to the 1/2. Oh my goodness. Can we finally take the antiderivative? Yes. Now that was pretty ugly, right? That was the hard part. Now let's do, and that was all algebra stuff. Except for this part. We did do one derivative over here. Okay. Now let's do the antiderivative. Let's get our answer. Now when we do our antiderivative, we have to add 1 and then divide by whatever our result is. Now, I like to kind of shortcut the process, and since this is a 5/2, I'm going to add a 2/2. That's the same as 1. You're right. Okay, when I go 5/2 plus 2/2, I get 7/2. This one, I add 2/2 to this one, I get a 5/2. And this one, I add a 2/2, and then I get a 3/2. Now, when you guys start dividing by fractions, you kind of get fast at this when you do it a lot. here, let me do one of them to show you guys. If I go u to the, 7 over 2, and I multiply this by the reciprocal of this, that would be 2 over 7. I would get, well, I guess I could just leave it 2 over 7. So there's two ways to write it. You can write 2u to the 7 over 2 over 7, or you can leave it with the fraction out in front. You can say 2 over 7 u to the 7 over 2. I think that's what I'm going to do. I'm going to put the fraction out in front like that. Okay, but it is going to be a little bit more work with the coefficient in front right here, because if I multiply 2 by 2 over 5, that's going to be a 4 over 5. So let's write our results. Okay, so we have 1/2 out in front, and now I'm writing out the antiderivatives up here. We have a 2 over 7 u to the 7 over 2 plus 4 over 5, and I did some mental math here. I went 2 times the reciprocal of 2 over 5. That's going to be 4 over 5. Wait, what's that? Should be minus? Oh, yeah. You're right. So minus. I was just trying to see if you're paying attention. And then we have u raised to the 5 over 2. And then the last one, we have 2 over 3, because that's the reciprocal of 3 over 2, times u to the 3 over 2. And then plus c. Wow. So that's our antiderivative. Do you guys remember what we're supposed to do next? No. We got to take the u's out and put the x's back in. Oh, that's disgusting. Yeah, I know. This is not a pretty thing. I'm going to leave the 1/2 out there, though.
The C stays.
Wait, should we let's multiply the 1/2 out. Why not? Okay, final answer. 2 over 14. And then u is 1 plus x squared. And we're raising that to the 7 over 2. Let's just leave it like that. And then we have 4 over 10. And then u is 1 plus x squared raised to the 5 over 2. U plus 2 over 6, 1 plus x squared, raised to the 3 over 2, and then we have a plus c. Now that c should be different than this other c, so we can signify that by saying this is c sub 1 and this is c sub 2, but it doesn't really matter. You just have to have a plus c. So there's our final answer, Stews. Man, that was crunchy. Okay, so and you also can simplify these. Dang, I don't want to simplify. This would be a 1 over 7. This would be a 2 over 5, and this would be a 1 over 3. And then you could probably see pretty quickly, if you start doing the derivatives of all these, how you would get right back to this. Wow. Yeah, good. Have fun with that.